Okay, part 2 of vectors. One of the things we talked about in the previous one is the initial point to the terminal point. Now, this was called vector A, that's its notation, and it's going to have some sort of direction and some sort of magnitude, and we can talk about the different ways you have that. However, if I have something that is the exact same length, but goes in the opposite direction, these are called, shockingly enough, opposite vectors. So in this case, this could be considered negative A. If I were to attempt to take A plus negative A, no one should be shocked to know that the answer is going to be 0 because you started someplace and came exactly back to where you started. And so the difference is 0. So the resultant of the two vectors is 0. Now, you could have parallel vectors. In this case, I have a vector here, A, and I have a vector here, B. And they are not the same length. They're not the same vector. They are indeed parallel because they have the same direction. Now, if I take two vectors that are in the same direction, I can simply take A, and I can attach and slide B over, and the result of A plus B is going to be exactly that. So for example, if I had A equals 2 inches and B equals 1 inch, we could say that the result is 3 inches in whatever direction this was going. So I can add vectors. To subtract vectors, not shockingly, you could simply take A minus B would simply be A and reversing B, starting at the head of the last vector, the tail of the first, and it moves back because in essence minus B is plus negative B. And so in our case we had a 2-inch vector minus a 1-inch vector equals 1 inch. Now, that's all fine if they are parallel or opposites. When they have different angles, this is where it becomes more imperative. Now, I have two vectors here. I have one vector that is 10 centimeters at 15 degrees. I have another vector here that is 5 centimeters at 45 degrees. We'll label this one A and this one B. Now, we've already figured out what A plus B looks like. So I have A, I'm going to take the tail of B, move it right to the end of A, and that's what it would look like. We would draw the resultant from the tail of the first to the head of the last. Just like that. So in essence, I would have 15 degrees, 10, 5 at 45. You'll notice I always draw the axes in so I have a clear indication of where each angle is. The resultant will be from tail of the first to head of the last. And finding that is going to be a little bit more tricky because I have no right angles. Now, I can also do 2A, and 2A would simply be this A plus another A. And of course it would be 20 units in length. And it would all be in the same exact direction. Now if I wanted to subtract 3B, I'm going to simply take this and reverse its direction. And so I have 1B, 2B, 3b. And in that case, my resultant is going to be from here to here. Now, we're going to have a whole lot of things that we're going to need to deal with. We're going to have a whole lot of things that we're going to need to deal with to find this resultant. First among them is to find the two lengths. So this is 20. Since this was 5, I have 3 of them, so it's 5, 5, 5, or 15 units. Now, I have a non-right triangle, so non-right triangles means law of sines or law of cosines. In our case, we're going to have this side and this side, and the best we can do is the angle in between. Now, if this is 15 degrees here, that means, according to parallel lines, we have an alternate interior angle of 15 degrees here. If this was 45 this way, it's now going to be significantly different. It's going to be 45 plus 180, or 225. Now, to find this angle in between, all I need to do is figure out from here around is 225. If this is 15, from here to here is 180. That means from here all the way to this side is 195. So obviously, to find this angle in the middle, it's going to be the big angle minus the small angle. 225 minus 195, or 30 degrees. Now you can't use the 30, 60, 90 because I have no 90s. But if I wanted to find the resultant, I would use the law of cosines and say r squared equals 20 squared plus 15 squared minus 2 times 20 times 15 cosine of 30 degrees. If you work this out, you will get r equals a value. Alright folks, through the magic of television, I've gone ahead and plugged in my law of cosines into a calculator, gotten 105. But you'll notice that is r squared. To get r, I'm going to have to square root that value. Second, square root, second, answer. And so the length of this new resultant, after going 20 in 15 degrees, 15 in 225 degrees, my resultant is 10.27. 10.27. Now that's only half the battle. I still have to find the angle, because again, a vector has both direction and angle. How do I get from standard position, which is the positive x-axis, all the way around to here? Well, we know we have 90. We know we have another 90 and another 90. What we don't know is how much is either here or here. In this case, what we could do is use the law of sines. By using the law of sines, I could find this entire angle. So, law of sines. Alright, again through the magic of television, I have a law of sines set up such that I have the sine of 30 over the opposite side, 10.27, equals the sine of x, which I don't know, over 15. By plugging it into the calculator, I come up with 0.73. Now the 0.73 is what sine of x equals. I need to use the inverse sine to find the actual answer. The answer is 47 degrees. Now folks, if the whole thing is 47, how do I find this bit? Well, 47 minus 15 would be 32. So 360 minus 32 means that I have 328 degrees. So my vector is at 1027 at 328 degrees. That is my full vector. It's going to be a lot of steps. It's going to be a lot of pictures, so you need to be patient as we work through these problems. The following three problems are your homework. You have 4 centimeters at 340 degrees. You have 3 centimeters at 45 degrees. Your job is to do one problem on one sheet of paper, or one side of a sheet. A plus 2B, draw a big picture, use the entire sheet for the work. Turn the paper over, A minus B. So you're going to have A, and then you're going to flip B around, bring it down, and A, so you have A minus B, and you're going to need another separate sheet of paper there, and finally 3A. So, go ahead, pause the video, write down your problems, get them done.